Hi folks, my name's Eric Slyman, and I'm excited to share our research with you today on interactive vision and language slice discovery. A fundamental task typical to vision and language models is to learn the relationship between image caption pairs and predict the similarity between the two. However, the nature of training these models on large-scale uncurated datasets from the internet leads to learning problematic associations of visio-linguistic information. Take this photo, for example, of Eileen Collins, the first woman to pilot a space shuttle, and the corresponding caption, an astronaut with the American flag. According to CLIP, a vision and language model, there's a similarity between this image and caption of 27%. All things considered, relatively high. However, when we change this caption to be inaccurately specified as a smiling housewife in an orange jumpsuit, we see the model demonstrate problematic behavior. The similarity between the image caption pair is increased from the one before, potentially signifying that the model has learned problematic associations between gender presentation and occupation. Prior work verifies this for some well-known biases. For example, that these models learn associations between gender presentation and types of clothing. This is typically a two-stage process. First, researchers collect a set of images capturing some text-based attribute over a bias dimension, and second, they look for patterns and similarity between that text-based attribute and semantically meaningful subgroups of images. When considering the image sets used in this analysis, there's a few things that should be true. For example, let's say we want to know if a model thinks that photos of people wearing glasses are biased towards being a CEO. Then our set of images should be large enough to make statements about this biased relationship with statistical significance, should capture a coherent visual representation of the concept glasses, and should be broadly representative of glasses-wearing people, different ages, skin tones, and gender presentations. And finally, if a bias is occurring, then it should demonstrate a systemic relationship between images in that set and captions which specify a CEO-like person. Manually collecting a set of images that fulfills all of these properties can be expensive and time-consuming. Ideally, it's something we'd automate, and of course, we're not the first to think about this problem in general. Slice discovery methods, or SDMs, originated to find subgroups of data along a shared dimension with consistent behavior. These methods typically operate over data with individually semantically meaningful dimensions like age and race. For example, to make a statement like Black females are systemically mispredicted to have income less than $50,000 a year on an income dataset. More recent work in this area considers images, but assumes labeled demographic information, and no work considers the vision and language case. In this work, we present VLSlice, an interactive tool inspired by traditional SDMs to help users discover good sets of images that are large, coherent, representative, and demonstrative of a systemic visio-linguistic relationship from a large unlabeled dataset via direct interaction with a vision and language model of interest. We refer to these sets of good images and the corresponding text with which they display a systemic relationship as slices. VLSlice first allows a user to query images for a domain of subjects and a bias dimension. In this case, we filter images to photos of people and score them on their affinity of CEO-ness. VLSlice then clusters the filtered images by visual similarity and text attribute affinity, outputting the clusters as candidate starting slices which a user can explore and filter. Once a user has identified a candidate slice, they can refine it by viewing similar and counterfactual clusters to their selection. Continuing our running example, we identify men's suits as a slice with consistently high affinity with CEO-ness and use similar clusters to find more relevant samples. Counterfactuals help to identify similar images with opposing behavior, such as people wearing suits that have a negative affinity with CEO-ness. This helps users avoid falling into a subset of images with pathologically consistent affinity. Finally, a user can validate the model's behavior on their slice by plotting all queried images' visual affinity with the slice against their intermodal similarity with the text attribute. For our slice capturing men's suits, we see a positive relationship, indicating that the model has a positive association between people wearing men's suits and being like a CEO. To validate the effectiveness of our interface, we conducted a user study comparing VLSlice with the representative control interface, ListSort, which provides simplified image search tooling. When evaluating participant performance over two different query scenarios, we find that VLSlice results in statistically significantly higher coherency and slice size at 95% confidence. We also find that participants rate VLSlice more favorably on a 7-point Likert scale when considering their experience with the interface and perceived ability to build good image sets. We report additional qualitative analysis in our paper. Thank you for your time. You can find a link to our paper, poster, and code all at the top right of this slide, and hope that you'll reach out to us with questions.